All right, welcome to this presentation about Blazor. We are going to talk about mastering, that's a big word, the new render modes in Blazor. So Blazor, some people love it, some people haven't tried it yet. And this is obviously a joke, but when it comes to Blazor, this is more true than I would imagine other frameworks, because there's a lot of people that just are anti-Blazor, but perhaps haven't tried it yet. So they might have heard that WebAssembly is loading slow, or they're comparing different frameworks and different load speeds with each other. But just because one framework might be faster, that doesn't necessarily mean that something else is slow. So I would love to kind of hear about your journey. So please write in the chat, are you using Blazor today? Do you want to use Blazor, or maybe you are a little bit unsure about Blazor, and we can pick that up later on. So my name is Jimmy Engström. I'm the lead developer at a company called Cab Group here in Sweden. I'm a Microsoft MVP for 11 years now, and I've been running Blazor in production since the release back in 2019. I'm the co-host of Coding After Work podcast, and we have a Twitch channel, we have a YouTube channel, and we talk to a lot of interesting people. We just dropped a new episode with Anthony Xu today, so please check that out if you like podcasting. And well, we are getting back to the original schedule when it comes to twitching as well, so please check that out if you want to learn more. I've written a couple of books. I've written this book, I have written this book, and I have written this book. And these are the only 3 Blazor books with raccoons on the cover, which is obviously the most important part. That was hard to say for some reason. And I got a couple of courses over on Don't Train, Getting Started, Deep Dive, and also an Auth one. And if you use the code Jimmy20, you will get 20% off. But enough about me. Let's talk about Blazor. And to talk about Blazor, we need to talk about this guy. This is Steve Sanderson. And back in 2017 at NDC Oslo, he had a WebAssembly talk. It was called Web Apps Can't Really Do That, Can They? So he thought, wouldn't it be kind of cool to run C# in the web browser? So he found an open source project with the C# runtime. It wasn't even maintained at that point. But he took that, compiled that to WebAssembly, and got a C# console app up and running. But Steve thought, you know what? This is not enough. I can take this further. And Steve is the man behind Knockout, if you remember that framework. It actually came out just before Angular. So he thought, I can use that Knockout experience and kind of get even more cool things in there. So when it takes the stage, he has a working example with a complete web framework. He had the name Blazor. He had working IntelliSense. And he showed that off on stage. And he kind of did that a little bit casually. So if you find that session, you should definitely check it out. He does it a little bit casually and kind of say, well, if this is something you're interested in, just let me know. And people was like, what is this? We had Damien Edwards on the podcast in the previous episode, and his jaws just dropped when he saw Blazor for the first time. It was just so amazing. The first version that Steve showed was WebAssembly, but the first version that was actually released was Blazor Server. And that is still the most used version of Blazor. So there are 3 interactive render modes, and that is Blazor Server or Interactive Server. We've got Blazor WebAssembly or Interactive WebAssembly, and then we have Blazor Hybrid. I'm going to talk about all of these as well. So when it comes to the different render modes, it's really all about very small differences. It's mostly about access and where things are running. So if we're running Blazor server, we get access to internal resources like databases on our network, for example, or the server CPU. If you're running Blazor WebAssembly, we got access to local resources. So inside of your computer, we're using your computing power, your CPU, your files, and so on. And also, when it comes to Blazor Hybrid, we can access the local resources, but not only through the web browser, but also through local access like Bluetooth or vibrations or anything like that on the actual device, on my iPhone or Android or whatever it may be. So let's dive into Blazor server and see what's happening there. With Blazor server, we got a server and we got some Razor components. The Razor components will render something. And here's where Blazor comes into the picture. Blazor has a render tree inside of it. So basically a in-memory representation of the DOM. So let's say that our Razor components are rendering a header and a button. Cool. Then we have the client or the web browser. So the web browser has a DOM as well as a little piece of JavaScript. The JavaScript is responsible for connecting the browser with the server using something called SignalR. Now, the server knows that, well, I haven't sent anything over to the client just yet. So it's going to grab that and it's going to push that over to the JavaScript. The JavaScript is then going to take that information and, well, update the DOM. Cool. So let's say now that I click the button and the event is going to go to the JavaScript over SignalR and then over to our Razor components. Our Razor components are going to run some code, whatever that may be, and update the DOM, or the render tree, I should say. And this is a very subtle change. It's Blazor rules with an S instead of a Z. So, okay, so we got that header or heading updated. Cool. But Blazor knows on the server it's keeping the state. So it knows what it already pushed over to the browser. So it knows that I already pushed over the button. I don't need to do that again. So it's only pushing over that particular change over to the JavaScript. It's not a complete representation here because it's not actually sending the HTML tags and stuff like that, but the gist of it is exactly this. And then the JavaScript is simply going to update the DOM. Perfect. When it comes to Blazor WebAssembly, we kind of need to understand WebAssembly. So to do that, we need to start with JavaScript. So basically what is happening is that when we run JavaScript inside of the web browser, we are downloading the JavaScript, we are parsing the JavaScript, and then we are compiling the JavaScript. All this is done inside of the web browser. Then the JIT interpreter is going to be able to run the JavaScript. With WebAssembly, we can kind of bypass some of that functionality because we can only download it. We don't need to parse it. We don't need to compile it because the JIT interpreter is going to understand what is happening. Now, what Microsoft did was that they took the mono runtime and they compiled that to WebAssembly. And here's the cool part. The .NET runtime compiled to WebAssembly is running your .NET standard DLLs. It is running your or Microsoft's framework DLLs. There's nothing special about these DLLs. They're not compiled to WebAssembly or anything like that. This is just the standard DLLs. It's the same DLLs that we will be able to run on the server. In .NET 6, we got something called AOT. So ahead of time compiled. So basically what we can do is we can take all of these DLLs and compile them to WebAssembly. The downside is that our WebAssembly file is going to be a whole lot larger, but the benefit here is that it's also going to be it's going to execute, it's going to start up faster as well. So if download size is not something that you're very worried about, this might be a solution. But there are also some internal stuff happening inside of Blazor that kind of makes AOT obsolete, because the things that are happening by default in Blazor is going to make it so fast that this is basically not a performance boost. The only thing that you should think about is that if you have a site that has very many, it updates the screen very often, well, then you might want to think about going the AOT route. But we're going to come back to footprint as well. Okay, so let's go back to this slide. So this is what Blazor server looks like. So we got the server, we got the Razor component, Blazor render tree, DOM, and some JavaScript. When it comes to WebAssembly, it is only about where things are running. We're now running everything inside of the web browser. We got the dotnet.wasm, so the .NET runtime compiled to WebAssembly. Same Razor component, same Blazor, same render tree. We still got some JavaScript up here, and we still got the DOM. The difference here is that we're not using SignalR anymore, we're using JavaScript interrupts, so it's going to be faster when it comes to updating as well. But the architecture is very similar. With .NET 8, we got some new render modes. They used to be called Blazor United. It's not called that anymore, but in some sessions and in some blog posts and stuff like that, they're still kind of referred to as Blazor United. That's why I kind of want to use that name here as well, just so that you know that Blazor United is the same thing that we're going to talk about now. But nowadays, it's just inside of Blazor. So we got a couple of things. We got static server-side rendering. We got streaming server-side rendering. We got per component render mode. And also we got something called an auto render mode. And we're going to go through all of this. Well, I'm going to do that right now. So static server-side rendering, that means that they've got the browser. It's going to send a request back to the server. The server is then going to render something and send that back to the web browser. Now this is the end of the whole communication. There's no SignalR involved, there's no WebAssembly involved. The button is not going to work. We just did the whole transaction. So this is very similar to MVC or web forms. It's just going to send a request, get a response, and then we're going to be done with it. Then we got streaming server-side rendering, which is something that you're going to see in a bit that I'm actually quite excited about. So what is happening is that we are doing a request, we are rendering something, then we might do something with the database, for example, a database call. We're getting some data. But while we're doing that, we can send back a response and also send back a fetch promise. So we're saying that we're going to get some more data. We don't know when, but we're going to get some more data. And as soon as that data is done, it's going to send that over the wire. Now, it's not an actual extra response here. It's a fetch promise that's just going to send that over the same connection, basically. But again, there's no WebAssembly involved. There's no SignalR involved in this at all, which is super cool. And we're going to see that in action in a bit as well. We also got something called per component render mode, and this I'm actually less excited about. There is some useful use cases for this, but the concept here is that we can run one component with WebAssembly, and we can also have SignalR connection connected so that we can do, well, server rendered components as well as server-side rendered or streaming or whatever we may want. We can mix that all day if you want to. Now the problem that occurs here is when it comes to dependency injection and keeping state, because the server-side rendered components are going to be one dependency injection. The WebAssembly one is going to be one dependency injection. And the SignalR one is going to live with the SignalR connection, which means that if we navigate away from a page that no longer has a SignalR connection, that connection is going to be broken and we're going to lose that state. So it's a little bit tricky to navigate that. So my recommendation, it's at least for .NET 8 and .NET 9, kind of keep it simple. Use it per page, if you will. So use all the pages in, all the components in one page should keep the same render state. That is going to be so much simpler. But I guess that depends on what you're building, as always. Rocky Latka, that I believe spoke at the last Trailblazer conference, has a solution for that by calling an API, for example. I know that Carl Franklin has one as well. I'm sure there are other solutions for that as well. Then we have auto mode. And auto mode is a really nice middle ground. Because what is happening is that we go to the site for the first time, and then we're going to have SignalR connected. So we're going to get that fast initial response, fast initial, what's the word I'm looking for? Interactivity. So we're going to get initial load fast. What is actually going to happen is that we're going to get a pre-rendering. So we're going to get a nice looking state from the beginning. Then SignalR is going to get connected. And then we're going to get interactivity fast. And then in the background, it's going to download all the things that we need for WebAssembly. So once that's done, the next time we go into the site, it's going to load the WebAssembly from the start. So we're going to remove that initial load time completely using this render mode. So what about Blazor Hybrid? Well, let's go back to the WebAssembly slide here. So we got the browser. We're running inside of .NET.WASM, Razor component, Blazor, render tree, DOM, all of that goodness. With Blazor Hybrid, we're now running on a device, on our iPhone, Android, macOS, Windows, Tyson. And then inside of .NET MAUI, which I know that Matt is going to talk about later today, we're running inside of .NET or .NET for iOS or Android. Same Razor components, same Blazor, same render tree. We're not using JavaScript or JavaScript interrupts or SignalR anymore, but we still have a DOM and we can mix that with native components as well. So using the same Razor components, using Blazor Server and Blazor WebAssembly, and of course static server-side rendering, we can reach the web. Using .NET MAUI, we can reach iOS, Android, macOS, Tyson, and Windows. And thanks to the Blazor WebView, we can also integrate this into WPF and WinForms. I mean, seriously, this is a really, really good time to be a Blazor developer. We can reach all these platforms with the stuff that we hopefully already know. So in .NET 8 and in .NET 9, there are two templates. It's the WebAssembly standalone template, which is only going to give us WebAssembly. So the template isn't that exciting. It is basically just a, and as you can see, this is an old slide. We got .NET 8 here, but it's the same for .NET 9. So the only really cool thing that we can do here is that we can do a PWA app, a progressive web app. All the other stuff is the same. When it comes to WebApp template, which you're going to see is the real hero here, is that Here we can configure the interactive render mode. So what render mode should we use? Should we use none, which is static server-side rendering, static or streaming, server, which is Blazor server, or interactive server as it's called, or WebAssembly, which is Blazor WebAssembly with pre-rendering. All of these render modes has a pre-rendering, which is kind of making this super cool. And we also got the auto mode here. We also have where should this interactivity live. Globally, that means that we're going to have that for all our pages. Or we can do it per page, or we can do it per component. So we can have different components having different render modes on the same page. Now, I'm not a fan of using page because everything is a component. The difference between a page and a component is basically an attribute. So, but sure, pages and components. So which one should we use? Let's take a look at that and see what we got here. So this is an app that I built. Let's zoom in just a little bit here. So this is, as you can see, mostly the original demo, the original file new here. So if we go into change render mode here and we go to SSR, that means that we're right now running this whole site as a server-side rendered component or a site. So if I reload the page here, you see that it's instant. Now, it's super fast. But it's rendered on the server, pushed over, and as you can see, if I click the button, nothing is going to happen because it's static. That's the whole idea with it. So that's one way that we can use Blazor. What we can do, we can post forms. So we could make this component working, but I don't have an example of that in this demo. But if the content is static, we don't need to change anything. We could definitely do it like this. Now, if I change the render mode, and I'm going to go with WebAssembly pre-rendered, and I'm going to clear the cache so we don't have anything loaded, and I'm going to reload the page. You see that we got static up here, and then it switches over to WebAssembly. Let me clear the cache again, and I'm going to show you again. Clicking in now, we got static content, so this is the pre-rendered content, and then WebAssembly is loaded, downloaded, and loaded, and replaced inside of this. Now, if I clear the cache once more, I click reload, and I start clicking like crazy here, nothing is going to happen until WebAssembly is fully loaded. And that's kind of the problem with this solution, if you will. It gives you the feeling that it is interactive because we have a button there, but it's actually not. So we can solve that if we pop into the code here. And what we can do is, pause for dramatic effect, we can add a little piece of code here. So we're going to do a disable. So this is just the HTML attribute. And we're going to say renderer info. This is actually a new thing in .NET 9, which means that we can access is interactive. So we don't need to ask it, are you currently running WebAssembly, or are you currently running server, or wherever it may be. We can just check, is the component running in an interactive environment right now. So if we pop back to our site here, I'm going to clear the cache again. I'm going to reload. You see that the button is now disabled. I'm clicking like crazy, and as soon as WebAssembly is loaded, the button becomes not disabled, and we can click the button. So this is one way that you can solve this state where it doesn't give you the impression that it is interactive, at least. And you can also like wrap the content that you're currently loading, so you don't need to see anything until the page is completely loaded. Now, if we would compare that to doing it without preloading, so we've got WebAssembly without preloading. We're not going to get anything from the server until the complete site has loaded. There are ways around this as well, but this is the gist of it. This is what is going to happen. Now, in the default WebAssembly template, you will get a progress bar, a spinner. So now if I clear the cache here again, let me see what's going on here. There we go. And I reload the page. You see here would normally be a spinner, and then as soon as the site has loaded, we're getting back there. Now, if we compare that to the WebAssembly one here, clear the cache, reload, we see that it's so much better from a user perspective. It feels like we're already inside of the site. We got a fast response, but the interactivity comes a little bit later. When it comes to auto mode, I'm actually not able to show that. I think, let's try it. I think it's actually already loaded. It only works the absolute first time you would do that. Let me see, it's actually, let me see, clear cache, reload. No, it's not doing what I want at all. Let me restart that one so that we know that we are in a good space. There we go. Let's go up here. Let's go with auto. I'm actually not entirely sure what's going on here. Oh, it's because I'm an idiot. We want auto pre-rendered, of course, because we want the static stuff happening. So if I reload this, let me reload the page once more. There we go. Let's pop in here. No, it's actually, it will only do that initial load if the time is less than, I believe, 100 milliseconds to load the whole thing. And running locally, it's hard to show that scenario. All right, so let's pop into the weather component here instead. So this is one of the issues when it comes to pre-rendering. So let's take a look at this one. So we got some random weather data. And if I clear the cache and I reload, we'll see that the static site rendered on the server with the random data. And then as soon as WebAssembly takes over, we're reloading the data again. We're loading the data twice. And since this is random data, we're also getting completely different values. Let me show you that once more. Reload, static, pre-rendered stuff from the server, and then it's reloading again. So to solve that, we can pop into, let me see here, the weather with state. I'm not going to go through every single step here because we're going to end up looking at what .NET 10 is going to offer us, which is so much better. But basically what we do is that we inject something called a persistent component state. Then, a little bit down here, we try to get, in this case we're using the onInitialized method when we are initializing the component. We're trying to get some code or data. We are trying to get the forecast data, And if we have something, we want to get that into a variable called forecasts. Then if forecast is null, we're simply going to, well, load the data. And then towards the end here, we are also saying register on persisting. So now Blazor think that now it's time to save this. We should check whether or not forecast is null. Do we have any data? And if we do, persist that as JSON, which is kind of nice. So we have this ability to store the state. So if you go back to the site here, and we go to weather with state, clear the cache, click reload, static, switching over to WebAssembly, and we still have that data. Because what is actually happening is that the pre-rendering is going to get the data from the server, randomize it, and also put a variable, a JSON variable inside of the DOM, so then when WebAssembly loads, it's going to be able to pick that up, which is really nice. I also have another example here, which kind of going to show you the streaming aspects of everything. So in this case, we're getting the randomized data. We are updating, we are going through each item, updating the DOM between each item, and we're waiting just a little bit between them. So if I go back to the counter and I go back to the weather, this is the experience that we would have if we just navigated inside of the site. Now the problem here is that the pre-rendered things are going to be pre-rendered completely until it's going to be sent over to the client. So if I would clear the cache here and I reload, now right now the server is pre-rendering the content. There we got the content back because it's rendering all those iterations before it's actually sending the data back. So what we can do is that we can pop in, and the only change we do is this attribute. We add stream rendering. So if I would run this one instead, I'm going to clear the cache and reload the page. So right now, it's still pre-rendering, but it's sending over each update using the static server-side rendering. So no signal wire is involved, no WebAssembly is involved until WebAssembly is taking over. But as you can see, we still have that problem because we don't have that persistent thing going on here. So I thought that I was super clever. I thought that I'm going to be able to solve this. This is going to be the best thing ever. So I created something called a StateManager, I call it. So basically what it does is that it's a component that has a method that I can send in. How do I get the state? How do I get the state that I want to work with? And also a key. So it kind of abstracts all of that code that you saw earlier. So instead of persisting component state subscription and all of that stuff, that lives inside of this component instead. So I thought that this is going to be revolutionize the usage of all of this stuff. And if you scroll down here, you see that the only thing that we have here is really a low data asynchronous, and it's returning a list of weather forecasts. So if the component needs the data, it's going to get the data, or if it's already loaded, it's going to get that. Really nice. So if we would go back here, and I would do this one instead, I'm going to reload the page. You see that it's static, server-side rendering, pushing over those changes, and as soon as it's done, we are now running in WebAssembly, and we're keeping the state. So in this case, it was basically just wrapping the content that I want to use with a component. Now in .NET 10, so basically what Microsoft did when I was kind of done with this component, I was super happy with it. Microsoft says, you know what, we got another idea. We got another idea that is pretty cool. So basically what we're going to do, we're going to pop into, I believe it's this component. Yes. So this component looks exactly the same as the other ones. I have a little bit, there's a little bit of difference actually. Is this the right one? No, this one. So the difference here is that I have a forecast service. Basically, I'm getting all of that stuff and all the randomizing data, and I put that into a service instead. So we're going to get a little bit less code from there. And I also have a list with the weather forecast class. So what I need to do is I need to add an attribute to this, and this is in .NET 10. So what I would do is I would add a supply parameter from PersistentComponentState. Longest attribute name in .NET history, I believe. I also believe that this is going to change. I'm not sure. I think I'm running preview 3 or something like that here, so I might actually have already changed. And then inside of onInitialized, I can pop in and say forecasts. If forecast is null, in that case, I want to load the data. So I can do it like this instead. So if forecast is null, load the data. If I already have a state, if all of that is handled for me. So let's save this. I'm going to copy this URL because I did not add that to the demo just yet. And let's pop in here. There we go. Boom. Static and WebAssembly. Attribute name. Well, basically it was the attribute name, right? Because just null checking whether or not we got data in the variable already, that's not even an issue. So basically 2 question marks and an attribute, and we got all of this state for free. Thank you, Microsoft. I really love this. This is so much better. I'm not going to spend a lot of time on per component, but I just want to show you briefly. I'm going to zoom out just a little bit. This is only about the loading time here. So I'm going to clear the cache. So on this side, we have on that side over there, we got a pre-rendered. So pre-rendered, auto, server, WebAssembly, and static server-side rendered. And on this side, we got no pre-rendering. So I kind of want to show you the impact of actually using pre-rendering. So I'm going to reload the page, and you'll see that this side still has the WebAssembly parts of this still haven't loaded completely, while the other side loads really, really fast. But if you take a look here on the top here, if you take a look at the auto one here, I'm going to reload, I'm going to clear the cache, I'm going to reload. Check when it switches over to WebAssembly. So when it's from static to WebAssembly. You see that it's static, 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 and switches over to WebAssembly at the same time as the no pre-rendering. So it's the same speed until we kind of get interactivity, but it's so much, the UX, the user experience is so much better this way. So let's pop back to the presentation here. So this is comparison between WebAssembly using the delayed mode. So this is running the WebAssembly standalone template in this case, and we got this one running the WebApp template. I just want to show you the difference in experience here. So I'm going to run these at the same time. You see that we got a spinner, it's loading the WebAssembly, and then we're kind of getting the data streamed. So in this case, we're running streaming server-side rendering. So it's streaming as it loads. If we also check here, if I rerun this one, you see that if you check at the top, it's server generated, and when it's switching over to WebAssembly, it's around the same time. It's pretty close, at least. So it switches over to WebAssembly at the same time as the first one is done, because, well, it takes a little bit of time to get there. It needs to load WebAssembly and all of that stuff. Now, I asked in a Swedish user group or a Facebook group, what would you like me to cover when it comes to a presentation like this? This was way back when. And people were very upset when it comes to the footprint, the loading time. So let's talk a little bit about that. So the loading, it's when people are talking about this, they're talking about the megabytes. It's always the megabytes. But I believe that it's the loading time, the perceived loading time, that is really the problem. And as you've seen, we can solve that by using pre-rendering. Now, Facebook, for example, at that time, this is a couple of years old data, to be honest, was 16 megabytes of JavaScript. Pinterest was over 6 megabytes. YouTube were a little bit more than 4. Twitter was, well, back then it was Twitter, a little bit more than 3. Stack Overflow 1.5. And the Blazor demo site was around 1.2. I believe it's actually a little bit smaller nowadays. And I mean, I'm not kind of comparing Facebook to the Blazor counter, but it's not about the amount of megabytes in most cases. It's really about the perceived speed. So what can we do? Well, we can use a progress bar. It's all about the perceived speed, so we can use that, and it's also default inside of the template. We got, what's going on? My clicker just went berserk. There we go. Sorry about that. So we can use server pre-render, as I've shown you. That's the simplest solution. Now, I've seen that Junichi Sakamoto is actually inside of the chat here, and we can use Junichi Sakamoto's pre-rendering. So basically what it does is that it's going to pre-render the content of the WebAssembly site at publish. So we're going to get SEO better, and we're going to get faster loads. And I created I did a YouTube YouTube video talking about this this NuGet package, and this is the difference. Hey, I'm twice double Jimmy. So this is comparison between just using WebAssembly compared to using Junichi's NuGet package. So let's see here. There we go. No, my clicker is acting up. There we go. So boom. This one using Junichi's library, super fast, pre-rendered, and the other one takes a little bit of time. So this is an option if you have static content. So this is going to be super fast, and in this case, this is actually static content, so that works well. We can also use auto mode, of course. We're going to get fast pre-rendering, faster interactivity. So that's really great as well. We can use ahead of time compiled. Now, we're not going to solve the loading issue or the download, because that is going to be larger, and actually it's also downloading the DLLs on top of that. So it's going to be a lot of stuff happening there. But there are some cases where AOT makes sense. And I'm going to show you one of those. This is my ZX Spectrum emulator. I'm going to switch over to my screen here and pop into my web browser. So this is a ZX Spectrum emulator written in C# running in Blazor, and it's running ahead of time compiled. So let's run this. This is actually running on .NET 8, I believe, still. I'm gonna load Manic Miner here. It is very slow right now. There we go. For some reason, my computer has been very slow for in recent days, so it's a little bit behind when it comes to updating right now. But this is kind of the scenario where you want to use AOT. You need fast screen updates. This is running, I believe it's running 25 frames per second, because it should be running 50, but I actually have it running at 25 at this moment. So this is one scenario where this might be useful. Now, while I have all of you here, I also want to do a shameless plug of the WASM extension. So this is a Visual Studio extension where it kind of helps you with Blazor development. So it adds create isolated CSS, it adds create isolated JavaScript, code behind, find component usages and all of that stuff. It can also move your namespaces to the _import file. It can extract to component. This is actually a feature that is now available in Visual Studio as well, but it wasn't back then. We got find component usages, so we can find all the components currently using this component. It can move code to a Razor file. So inside of Visual Studio, we can select some files or code and move that code to a code behind file. But I really enjoy using Razor files, so I kind of want to move it the other way around. So this one would do that for you. We can switch between files, so Control-Alt-N will switch between CSS, JavaScript, Razor file, everything that is inside of in a hierarchy inside of Visual Studio, basically. This works for any file, really. Doesn't have anything to do with Blazor. And this was the first thing that we developed, the route thing. So we can find all the routes inside of Blazor, which is really nice thing. And it can also generate some BUnit tests if you want to. This is a very beta feature, it's not complete in any way, but it might help you just a little bit to get where you need to be. So let's pop back to the presentation. There we go. So we talked about the WASM extension. We talked about what it can do. Let's save the questions till, well, in just a couple of minutes, and we'll do them together with Sean, I guess. So, WebApp template or the WebAssembly standalone, or should we use server-side rendering? Well, it's always depends on what you're doing, right? But when it comes to the WebAssembly standalone template, you only have one choice, WebAssembly. You can't do any pre-rendering or anything like that. When it comes to the WebApp template, you can choose to have all the hosting models, WebAssembly, server, auto, server-side rendering, all of these different choices are available to you. So if I'm building the downside of using the WebApp template is that you need a server that can run ASP.NET. That's the only reason why you should not use it. If you have that, you want to use it. You want to use Azure Static Web Apps, for example, or GitHub Pages. That's the only scenario that I see where the WebAssembly standalone template is the better choice. Now, when it comes to the WebApp template or the WebAssembly standalone template, if we have authentication, what is actually happening is that authentication or the website, the WebAssembly, is going to be downloaded. It's going to boot up. It's going to check, oh, I'm not authenticated. Redirect you to Enter ID, for example. Authenticate you. Redirect you back to the WebAssembly site. And again, well, now it's cached, but it still needs to load all of that stuff into memory and start up. So we're going to hit that initial load twice if we're using authentication. Now, I have an example here. This is a site that I've been working on at work. This is not the state that it's in right now. It is also, full disclosure, running locally on my machine. So this is not optimized code in any way. So it is way slower than it is in production. But I kind of want to show you the difference between using the WebApp template and using the WebAssembly template, and also in combination with authentication. So check this out. Boom. The WebApp template is already done. Now this one is still waiting, is still loading. It has been authenticated, it's loading, and boom, we got the data. This is the same site, same data source, same APIs. The only difference is that this one is running the WebApp template and is authenticated against the server, not against the web browser as over here. Let me show you that once more, because it is quite mind-blowing, at least to me. Boom, done. We're still not in an interactive mode. We're still kind of waiting for that. That is not going to be much faster than the other one. But we have all the data there. You can start clicking around and start doing your thing, basically. So to close this up, should we go all in Blazor? Well, it is as always. What are your needs? It depends. What are your team good at? Is it production ready? Yes, it is. Should you invest time as a .NET developer exploring Blazor? Yes. You might even gain some speed, at least, when it comes compared to Angular Reactor View. So will it replace Angular Reactor View? Yes, for some developers. I haven't written a line of JavaScript in years now, which is kind of refreshing, to be honest. So thank you so much for listening. And if you have any questions, I'll stick around for a couple of more minutes. And please email me or reach out in any way or form. I'm on X or on Blue Sky and all of that stuff. And please check out the Coding After Work podcast or stream.